So now that we've created multiple smart contracts in our IDE, including a application, which essentially was a will, right? That actually acts to allocate funds on the behalf of somebody after they are deceased. Okay, let's make one more smart contract, and this time let's actually build our own cryptocurrency. So let's build a subcurrency, and we're going to leverage we're going to use Solidity and leverage the Ethereum blockchain to build our subcurrency. So this is pretty exciting stuff. So this is a great way to not only solidify our coding, solidify our building of smart contracts, but also get a better sense of tokenomics in general and cryptocurrency. Okay, so what you want to do first up is you want to go back to the main page by clicking on that alien head with the headphones. You see this little alien head guy over here. Interesting choice. Okay, and then we want to make a new file. And let's call this file subcurrency.solidity. Okay. So what we're going to do with subcurrency is the same thing that we do with our exercise Solidity, the same thing that we did with our will contract. We're just going to bring in Solidity first, right? So we're going to start by writing pragma Solidity, and we're going to grab the version, any version between 0.7 here and 0.9. Okay. So we're essentially building our own crypto coin. So in order to build our own crypto coin, we're going to do the same thing that we've been doing before. We're going to set up the coin to be a contract. We're going to declare our coin as a contract, right? Because our crypto coin is going to have a contract. And we're going to do that by typing in contract, coin, that's the name, and then bringing in our curly brackets for the object of information that we will pass into it. Now, before we dive deeper into this, what exactly do we want our crypto coin to do? So what we're going to want is for the contract, what we're going to want is that the contract allows only the creator to create new coins, okay? So we don't want anybody to be coming into our contract, taking our contract, and then making more coins. We want to be the only one that could actually make coins. So we're going to look at how we would create issuance with the parameters of that. You know, that's an important fundamental. And then something else that we're going to add is that anyone can actually send coins to each other without a need for registering. All right. So there's no need for username, password. All you actually need is just the Ethereum key pair. So you need that information of the address and the amount. All right. And then you can send it, and then you can send over your coins that way. Okay, so that's the functionality of our contract coin. That's what we want to do. So how do we start with this? Well, it sounds like we're going to need two state variables that we're going to have to create here. One is going to be for the minter, right? For the person who's going to be minting the tokens. And then another one's going to be balances to keep track of the balances. All right. And our minter, of course, that's going to be the address, right? Because we're going to want the creator to be the owner. So what we're going to do is say address minter, and we're going to make it public, right? Because this way it can be visible and we can actually access it outside of the contract. And then our semicolon, right? So this is our first state variable. Now, what else? We said balances. So what should balances be? Well, it should be an integer, right? But actually it should be addresses that carry the numbers. So address. And then each address we should be able to keep track of. And how do we do that? Well, as we saw previously in our will smart contract, we did that with mapping. And if you're still unfamiliar with mapping, you can go to the glossary and check it out. But don't worry if you're still not getting it and you're totally new. We're going to be working with mapping a lot more coming up. So in order to set our balances for mapping, we have to bring in mapping. Okay. And then we're going to set our address to a key store value, integers. Get rid of that. Let me zoom in. Get rid of that question mark. Hopefully you can see that better. And are we missing anything else here? Well, we want balances to be public as well, right? So we got to remember that the keyword public, what it's doing is it's making the variables here accessible, essentially. Accessible from other contracts. Okay. All right. So now we have set up our variables. Next up, let's bring in our special constructor function, okay? And let's set the constructor so that when we deploy the contract, our minter is going to equal the person that's calling the contract. So that's going to be message.sender, right? Remember, this is a global variable, and then sender and then sender actually checks for the caller, the person who's calling the contract. All right. So we're going to set the minter to the message sender, And let's remember that the constructor is only called when we deploy contract, or not called, say constructor only runs, let's say that, when we deploy contract. Okay, so now we have our constructor set up to the minter. What should we do next, right? So what are we trying to do? Remember, the contract that we are creating, we want to allow only the creator to create new coins, okay? And then we want anyone to be able to send coins to each other, right? That's the second functionality here that we want. So let's just focus for now on the minting, and then we will do the sending, right? So let's keep working on this minting. So let's actually make a function for minting, right? So let's create a function called mint. And what's this going to take for its arguments? What should we add for the function argument, for the arguments for function mint? Well, what are we going to need in order to mint this function? Well, first of all, let's put our curly brackets, and let's just think about, what does this function need to do? Well, we want to make new coins and send them to an address, right? That's one. And then the other thing we want to do is we want to make sure that only the owner can send these coins, right? So then let's add two arguments to our function, the receiver and amount. And amount will be integer, right? And the receiver is going to have to be an address, okay? So now we have two arguments. So how do we make sure that only the owner can send these coins? Well, we can use require, right, our condition, and we can say that the message.sender has to be equal to what? Well, to what we defined here, right? The minter, right? Our minter, that's going to be the owner. So the message sender here has to equal the minter, okay? And then now, how do we actually make the new coins and send them? Well, we can use our balances, right? Which is keeping track of our mapping. So we could actually say balances and then create our list here, so of receiver, all right? And this could equal what exactly? Well, we want it to equal the amount, right? But we don't want it to just equal the amount, because if we do that, then every time that we mint, it's just going to revert to the amount, and it's not going to keep track of what we had before. So how do we do it so that it equals the balancers plus the amount? That it equals all the balances, receiver, addresses plus the amount. Well, we can say balancers, receiver plus the amount, right? And then another way to write that more efficiently is we can just write plus equals amount, because that actually means the same thing as that. So let's not forget our semicolons. I always forget them. And okay, and then finally this function as well, we should make it public, right? Okay, so now we have a function to make new coins and send to an address. We keep track of it that way. And then we also require that it's just the owner that can do this. Okay, so what about events? We talked about events and we haven't really used event yet. So shouldn't we make an event to allow our clients to react to the changes happening in our contract? And to do that, we could actually use the event. We actually use the event sent, right? So sent essentially sent actually takes 3 arguments. We're going to have 2 addresses, right? We want the address from, we want address to, and then we want an amount, right? And that's really it, right? So let's actually take this and move this to the top. And now we could actually emit this when we create the sending function. So that way our clients can actually react and see from the address from where it's coming from, where it's going, the amount. the amount, and we will emit this event when we create our send function, right? Because we have a mint function for minting new coins, but we don't have a send function yet for sending out coins that already exist. Okay, so let's create a function where we can send any amount of coins to an existing address, right? How are we going to do that? Well, it's going to be very similar with the mint, right? We're going to need an address and we're going to need an amount. So we're going to say function send. We'll take an address, receiver, and integer, which will be an amount. We're going to put in our curly brackets. And now we can actually update our balances, right? So we're going to say balances is going to be what? Well, we're going to have balances of the message sender, person who is sending. We're also going to have balances of the person who's receiving, right? This is what we want to, oops. Wait, am I putting the I before the E, or is it the E before the I? I think it's E before I, right? Let me just correct the I'm actually going to fix my typo here. I think receiver is EI. Do that, and I'm just changing the word receiver everywhere here. I think that's it, right? Yeah. So we have the balances of the message sender that when we send, we want to change this amount. So if we're sending, what should happen to the balance of the message sender? Well, it should go down, right? The amount should decrease. And just like we did before, we also want to take into consideration the previous balance. So we can do that. So pause the video and see if you can actually write out the balances for both message sender and receiver. Okay, so hopefully you had some success with that. Let's do it together. So for the message sender, what you want to do would just be minus equal, right? Because you are reducing the amount, okay? And for the receiver, well, they're going to be getting the new amount. So you want to actually increase whatever the amount was. And it's as easy as that, okay? Okay, so this looks like we could be done, but let me just propose this done, and we could be, but this isn't really foolproof, right? Like, let's say, for example, if somebody wants to send an amount that's greater than what they have, like if you want to send money that you don't actually have, you could technically do this. There is no logic anywhere here saying that you can't do that. So it would be prudent for us to at least write the logic for that, right? So my first question is, where would we write that logic? Well, it would be back in the function send, right? We want to say that, no, you can't just send any amount if you don't have the balance to do it. We want to make sure that you have the balance. Now, you can mint any amount because you're making new coins, and you can create as many as you want. So it doesn't really matter in the function mint. But here, we don't want other people to just be making coins that don't exist and then sending them. That would just mess everything up, right? Okay, I was getting into that. Oh, and the other thing is we do want our function send to be public as well. All right, so how do we do this? Well, we can create another conditional statement. We can say, well, let's require the amount to be greater than what, and then run this. So you know what? Go ahead and try to at least write out the conditional statement to say, require the amount to be greater than X, and then run this. Should be true. So go ahead, pause the video, and give that your best shot. All right, so hopefully you had some success with that. If not, we're going to try that together. So what we're going to say is we're going to make an if statement, and we're going to say if the amount, okay, is greater than what? The balance is, right? And what balances specifically? Well, the balances of whom? The balance is not of the receiver, right? The balance is of message.sender. So if this is true, if the amount is greater, we can actually just run a special keyword, revert. And revert will actually stop this transaction from happening and provide the information regarding the transaction, all right? And so in order to do this, why don't we create another variable, and use a new special keyword we haven't looked at. And this is actually going to be error. And when we use error, we are letting Solidity know that it is an error. So we're going to say insufficient balance. And it's going to take two integers, which is going to be the request, right? So the amount requested and then the amount available, right? So this actually will show the amount that's just available versus the amount that's requested. Okay. These are the parameters that we can set, and now we could actually set the requested and the available to the amount and to the balance of what the message sender is. And we can do that now by bringing this in. So we could actually say revert to insufficient balance, and then we can bring it in like an object and then set the parameters up, right? So we want requested and we want amount. Oh, sorry, we want available. So go ahead and pause the video and try to figure out what requested should be and what available should be in order for this function to work. And yeah, this is getting a little bit more tricky, but I believe in you. I believe if you go step by step, you can figure it out. Okay, so give it your best shot. All right, so hopefully you had some success. If not, really, don't worry about it. It is a little bit tricky to follow here. We're going to go over it all again when we're done with the function. We're almost there. So if you did get it, awesome. That's amazing. But let's just look at it together now. So what did we do? We created a function called send, right? Takes two arguments, the receiver and the amount. We set it visible outside of the contract. Now we say, don't even worry about this right now. So we say that, what does this function actually do? Well, the balances, right, our balances for our mapping up here, so of our addresses from the receiver should go up, right? Because whoever is going to be receiving the tokens, they're going to get that balance. And then the balances of the sender should go down. And what do they go up and down by? Well, by the amount that they put in for the function send, okay? Okay, following me so far? I hope so. Next. Well, we realized after that, we said, hey, wait a minute. What if they want to send an amount that's greater than they have? They shouldn't be able to do that because then they'd be effectively creating coins, right? We don't want them to do that. So we create a conditional statement to prevent them from doing that. And so we make an if statement and we say if the amount is greater than the balance of the person that wants to call the contract, right? So if the amount is more than the available balance that they have, then we're going to run this error. And we wrote this error here called insufficient balance, all right? And insufficient balance takes two arguments here, requested and available. And what we do is we use the special revert keyword, okay? And the revert keyword is going to cancel this, and it's going to revert to this instead. And what it's going to revert to is the error message from the insufficient balance, which is actually going to show the requested amount and what's actually available. So requested should be what then? Well, it should be the amount, right? And what about what's available? What do we want to show? Well, we want to show the balances of the message sender, okay? So let me put the semicolons, run a little save. Actually, wait, what am I talking about? We don't need any semicolons for this because we're actually writing in an object properties and we're aligning the properties up. So that's a mistake. Instead of a semicolon here, we should actually add a comma. And then we can't forget our semicolon to end this phrase, right? This is all a phrase, and we want to end the phrase over there. Okay, so I just did some debugging as I went along. If you hit save on your IDE as you go along, you're going to get the error messages, and you can fix them as you go. So if you see any typos or anything, you can fix them along the way. I'd like to save it for the end, for the last ones, because that way you get a chance to actually go through the process of what it's like to actually try to deploy something and run it, and then deal with those errors after. Even if you are trying your best to debug along the way, you always run into things. So actually that's it. That's the coin contract. We've effectively created a contract that allows only the creator to create new coins, right, with the mint function. And then anyone can send coins to each other without a need to register. And that's what the send function. And we make sure that they can't make coins. And we make sure that only the message sender can mint new coins. All right, so only the person that's calling the contract. All right, so that's pretty awesome. So go ahead and compile this and deploy it. And after you deploy it, congratulations, you have created your very first sub currency contract. It's very basic, but we did go over some key fundamentals here. We even used the sent event. We worked with our constructor, and we even brought in some error work. So nicely done getting through these more difficult Solidity fundamental contracts. I think now you are ready. You are ready to actually develop smart contracts from scratch and build our own development environment together to effectively create a decentralized digital banking system for yield farming, our very own application. So we still got a mountain to climb together, but we're going to do it one step at a time. Take breaks, have fun along the way, and make sure that we understand every point and part as we go along. So take this opportunity to take a break, maybe go back to the things that maybe go back to the parts where you weren't so sure about, recheck those videos, do a couple more exercises. And when you're feeling confident, when you feel good about where you're standing and you have good about where you stand and you want to keep going, I will see you in the next video. Okay, bye-bye for now. Okay, so why don't we go ahead and deploy this contract, see if this contract actually works, if we can create our own coin, and if all these functions are working. And now I want you to look through all the code if you've been coding along, right? Are we forgetting something? Because I actually forgot one thing when I just reviewed it now, and I'm looking at it, I'm like, oh, wait a minute, something very important, very, very important. And it has to do, I'll give you a hint, it has to do with our event. Now, we say that events allow the clients to react to specific contract changes that you declare, right? But let's specify this even more. So what really is an event? Well, let me just paste something in for you to read here. Oops, you're not going to be able to read that. All right, so an event, when we think of an event, we're thinking about two things. We need to emit an event, first of all, so we set up the event and then we need to emit it. And what does the event actually keep? Well, it stores arguments, right? And these are the arguments, address from, address to, and the amount. And these logs are actually stored on the Ethereum blockchain, and they're accessible using the address of the contract till the contract is present. But what are we missing in this contract? In our send function, right? What are we missing? What we forgot to do here is we forgot to actually emit our event, and we want to emit the event when we send our function, in our function, right? Because when we send, after it's been sent, then it's been sent. So that's where we want to actually emit our event. And so in order to emit it, what we want to do is we use the emit keyword. And this is quite a standard pattern, right? When you create an event, then you need to emit that event. So we're going to do emit, and what is the event that we're emitting? Well, it's sent, right? So sent. And then we bring in our arguments. What are the three arguments? Well, remember, for our sent, we have an address from, an address to, and an amount. So what is the address from? Well, we want to send from the person who's calling the contract. So that would be the message sender, right? Now, where do we want to send it to? The address to. Well, we want to send that to the person that is receiving, right? In our function. Here we have an input where we can say who's receiving it. So that's where we want it to go. Hopefully that's intuitive, right? Receiver. And then finally, what's the other, the final argument is let me go back. It's the amount, right? And that makes sense, right? So this should actually look pretty logical. This should look pretty logical to you when you're looking at this. You should say, hey, wait a minute. This is an event, and when we're sending the event, we need to check the three arguments. So the message sender, who's the message sender? So the person that's sending, all right? The receiver, who's receiving, and then the amount, right? And that receiver, we're actually going to, and the receiver is the person that we want to receive that amount, right? So that is the final piece of the puzzle that we were missing here, all right? And hopefully by stopping and adding this all the way at the very end, it kind of ties the whole thing together. Hopefully the contract is now tied together. All right, so enough harping on the event and the emitting. We're going to be creating many events in our final project. We're creating our own decentralized bank, so we're going to be emitting, transferring from. There's a lot of different events we're going to look at, and we're going to look at them later. So you don't have to get so don't get too worried right now. So don't get too worried or hung up on these events right now. I just wanted to introduce you to this at the end here. In a final swoop. All right, so let's go ahead and actually deploy. So let's save, make sure we're not running into any errors. And when you hit Command S, it's the same thing as compiling, right? It's, you see me hitting the compile, sometimes Command S, but it's the same thing. So we click compile. All right, so we've successfully compiled. All right, let's switch to the JavaScript VM Berlin. So I'm just gonna have some fresh accounts. We've got 10 fresh accounts. Make sure we're on the first account over here. Let's actually copy the clipboard from the first account. Here. Now let's go ahead and deploy. Let's deploy this contract. All right, and looks like we have successfully deployed the contract. And if you look, we have a successful transaction, and now we have our two functions. We've got a mint function and a send function. All right, so we've got two functions over here, mint and send. Awesome. So let's see if this works. Let's see if things are working. All right. Let's say we go to an account. Let's say we switch up here and we switch to the fourth account. Let's copy this. Now let's say from the fourth account, we want to mint ourselves a bunch of tokens, right? We're the fourth account, so we're going to copy and paste the fourth account here from our fourth account, and we want 1,000. Actually we're feeling greedy. We want 10,000. So we're going to click on transact. What do you think is going to happen? Well, we click on transact and notice that we get a reversion error. We can't actually mint. All right. Now, why is that? Well, what if we switch to the second account? So we go to the second account. All right. We're going to the account number 2 over here. Let's copy this. And let's mint for ourselves in the second account instead. From the second account, 10,000 tokens. Let's transact. Error again. Well, what's going on here? How come I can't mint? I thought, Clarian, I thought you said this was going to work. It's not working. All right. Well, what if we switch to the first account? The account that created the contract, right? Let's paste this in. And we're going to mint 10,000 for ourselves. So the receiver is going to take the same contract. All right. Let's see that. And let's transact. Boom. Would you look at that? We have a successful transaction. So what happened? What happened here? Well, hopefully you figured it out, right? Hopefully you're like, all right, I get it, Clarian. But if you're not sure, just think about it. We created a mint function, but we required that the message sender equals the minter, right? And we set our minter, and we sent our minter to equal the message sender in our constructor. So when we deploy, the minter gets the message sender address, right? And then message sender has to be that person who's calling. So by doing this, we actually create a security protocol where nobody else can mint new coins except for us. We're the ones who created it. We're the only ones who are allowed to make new coins. That is rule number 1. These are your tokens. You don't want anyone just to other people to make your tokens. So now we're feeling generous, right? We've got 10,000 tokens. We can make as much as we want. We're like the feds. We're just going to start printing. So let's go ahead and try something else. Let's go to the second account. Let's copy the address. Let's go back from our message sender account. Oh, sometimes my thing freezes up. Back to the first account like that. Let's paste this in, the second address, and let's send our second address, our friend Timmy. Hey, Timmy over there, 10,000. Look at that. Timmy now has 10,000. Right? And so now Timmy should actually have 10,000. So let's say we switch to the second account. Let's be Timmy for a second. So Timmy has 10,000 tokens now. So Timmy can say, hey, wait a minute. this is great. I got 10,000, but I need to pay my rent. I'm gonna just I'm gonna send 5,000 to Uniswap and get some cash out on exchange, or I don't know, whatever. I need to pay my rent. So what Timmy's gonna do? We're gonna say that we're gonna say that this account number 5 over here. We'll take the 5th account. We're gonna say the 5th account is like a Uniswap, Ethereum exchange, whatever. And then we go back to our 2nd account, right? Because it's got to be from the account that actually has the money. And we're going to say 5,000 of these tokens are going to be sent over to this new address. Timmy's going to send half of his money out. We're going to hit transact. And if you look at that, we have a successful transaction. It works. But what if we want to send now 50,000? It doesn't work, right? Because we don't have that balance. We requested 50,000, but if you look now at our transaction, we can see what's available. The only thing we have available is 5,000, and we actually set that up in our insufficient balance error message, and now it is working as well. All right? So this is it. This is your very own coin. This is your very own coin. And if you want to customize this, if you want to do more research, this is a starting point for you. So go ahead and review everything, go through all the functions. Remember, we've got our constructor, our minting function, our send function. There's a lot more that we can build, right, from here. This is just a setting stone. This is just the stepping stones. And we are going to build. When we get to the final project, we're building out fully simulated ERC20s, right, with approvals that hook up to the MetaMask and have approvals to run with transfer froms and third-party transferring. All of that's going to come later on. But if you want to do some research on your own now, read up more on ERC20 tokens, read up more on what you would like to add, and think about what you would like to add. What sort of functionalities would you like to add for your own token, for your own contract token? So make sure everything's working, deploy it, test it out. And once everything is working, congratulations, you've created your very own crypto token. Welcome to the cryptoverse. I'll see you in the next video.